Hello everyone, and welcome to 7th grade Math Module 3, Expressions and Equations. In this video, we're looking at Lesson 7, Understanding Equations. Our learning goal is to make sure we can analyze word problems to write expressions and equations, then show whether or not a given value is a solution to an equation. This will help us to master Standard 7 EEB3, solve multi-step real-life and mathematical problems posed with positive and negative rational numbers in any form using tools strategically. And Standard 7 EEB4, use variables to represent quantities in the real world or mathematical problems and construct simple equations and inequalities to solve problems by reasoning about the quantities. Before we begin, let's review some relevant vocabulary. Remember, the variable is a letter or symbol that represents a number, such as x. An equation is a statement of equality between two expressions. It will always have an equal sign. A number sentence is a statement of equality or an equation between two numerical expressions. So it's an equation with no variables. And a solution is an equation with one variable is a number that, when substituted for the variable in both expressions, makes the equation a true number sentence. So for example, with our equations to the right, 3x plus 2 equals 17, our solution is that x equals 5. And we can evaluate the equation by turning it into a number sentence of 3 times 5 plus 2, which does equal 17. We are going to also continue using our steps for solving 7th grade algebra problems by first distributing anywhere we can use the distributive property, then combining like terms, then undoing addition or subtraction with the inverse operation, undoing multiplication or division with the inverse operation, and checking our answers. Your brother is going away to college, so you no longer have to share a bedroom. You decide to redecorate a wall by hanging 2 new posters on a wall. The wall is 14 feet wide, and each poster is 4 feet wide. You want to place the posters on the wall so that the distance from the edge of each poster to the nearest edge of the wall is the same as the distance between the posters as shown in the diagram below. Determine that distance. So the first thing we need to do when looking at this problem is we need to find a way to represent with our numbers what is happening. We have a lovely diagram where we can see the total length of the wall, the length of each poster, and then we have the space put out for our distance between, and we know it's the same, but we don't have a number for it. That's what we're looking for. So one way we could solve this arithmetically is we could take our total length of the wall, and we could subtract away the amount of distance that the posters will cover. So 14 minus 4 is 10, and 10 minus 4 is 6. So we know that we have 6 feet of space to use in between our posters and the remaining parts of the wall. Since we want all 3 pieces to be equal, we can divide 6 into 3 equal parts, which gets us 2 feet in between each. But what about representing this equation algebraically? We can take the information we know and write an expression to represent what we have here. So we could represent each of those values we don't know in blue with the letter x. We can represent the length of our poster, our purple value, with 4, and we know that it totals to 14 feet. So we can say x plus 4 plus x plus 4 plus x equals 14 feet. We then can combine our like terms to write our equation in standard form. Since our x's are like terms, we can add them together and see that we have 3 x's, 3 times x. And because we have 2 4's being added together, that is the same as 2 times 4, which is 8. So our equation in standard form is 3x plus 8 equals 14. You can pause the video now to try to solve this equation using our inverse operations and our steps from the beginning of the video. How did it go? Since we no longer have anything to combine, since we already combined those like terms when we rewrote our expression in standard form, the first thing we need to do is undo our addition with subtraction. So we subtract 8 from both sides of our equation, and our new equation is going to be 3x equals 6. Now the only operation that is left to undo is multiplication, so we will divide both sides of our equation by the number being multiplied with our variable, 3. And then we are left with x equals 2. So this is we can see that we get the same answer of 2 feet for the distances between our posters. If we then wanted to check that this was correct, we could evaluate our expression for x equals 2 by replacing the x with 2 and doing 3 times that 2, which is 6, and adding 6 to 8, which is 14. Since 14 is equal to 14, then our equation was solved correctly, and we do have 2 feet in between our posters and our walls. The ages of 3 sisters are consecutive integers. The sum of their ages is 45. Calculate their ages. First, we're going to use a tape diagram to help us to find the ages of these 3 sisters. I've used a just regular tape diagram of X to represent the unknown age of our youngest sister. Then, I am using a tape diagram for the middle sister, showing that she is X, the age of the first sister, but she is 1 year older, so I added 1 to the end. Because it's consecutive, it would be the next number. Then the third oldest sister would be X plus 2, because she would be 1 year older than the middle sister and 2 years older than the first. So maybe their ages are 5, 6, and 7. Maybe they're 10, 11, and 12. All we know, aside from this tape diagram, is if we add them together, we get 45. So what I can do with my tape diagram now is, since they add to 45, and I know that I'm going to be adding some 3 individual years here, I can take my 45 and subtract away the 3 from my tape diagram to find that the X piece, this piece that's shared by all 3 sisters, is equal to 42 when you put all 3 of those tape diagrams together. Because there are those 3 X's, those 3 large unknown pieces there, I can take that 42 and divide it by 3 to see how many would go in those large boxes for each of my tape diagrams in each of these sisters. 42 divided by 3 is 14. So that tells me that our youngest sister is 14 years old, our middle sister is 14 plus 1, which is 15, and then our oldest is 14 plus 2, which is 16. So they are 14, 15, and 16. So keeping in mind the same relationship here, if the youngest sister is X years old, you guys can pause the video here to write an expression to represent each of the sisters' ages. One for the youngest, one for the middle, and one for the oldest. How did it go? If you use the information from our tape diagrams above to write some expressions representing the ages of these sisters, you would see that the youngest's age could be represented by X, the middle could be represented by X plus 1, and the oldest could be represented by X plus 2. So now that we have expressions to represent the ages of all 3 of our sisters, we can put them together to make an equation. Remember again that the ages of all of our sisters together was 45. So you can pause the video here to take these expressions, and knowing that they total to 45, to write your own equation. How did it go? If you went to write your equation, you should have ended up with the age of the youngest plus the age of the middle plus the age of the oldest, or X plus 1 plus X plus 2 equals 45. In order then to have this in simplest form or standard form, we would have to combine any like terms or distribute to get rid of our parentheses. Since nothing is being multiplied by what is in the parentheses, we can use the associative property to regroup what is in our parentheses with things outside. So basically, we can just ignore those and use our combining like terms to do 3 x's, 3 times x, and then 1 plus 2 is 3. So our equation in standard form is 3x plus 3 equals 45. So now we're going to determine if our answer from part A is a solution to the equation we wrote in part B. Since we already have a value for x, we can just evaluate our expression when x equals the 14 that we got for the age of the youngest sister up here. You can pause the video now to try to evaluate this expression when x is 14. How did it go? If you replaced x with 14, You should have been doing 3 times 14 for 3 times x and gotten 42. Then 42 plus 3 gets us 45. And since 45 is 45, then 14 is the correct solution to this equation and is the age of our youngest sister. What does this make you wonder about writing equations from word problems or using values that you have to evaluate your equations? Write your questions down so that you can look up your answers online or ask a classmate or teacher for help. Thanks for watching, and remember when you're trying this on your own, if you learned from your failures, then you succeeded.